Hello. Now we demonstrate how to run UniBench for ArangoDB. So first of all, we clone the UniBench and change the working directory to UniBench2. And we change the parameter of the LDBC and UniBench to configure the skew factor. So we configure the LDBC skew factor 1 and use the default serializers. And similarly, we use the skew factor 1 to the multimodal data generation. And then we restore the dependency and compile the UniBench. We combine the LDBC as a Maven project, and we combine the UniBench as SBT project. And the data generation consists of 2 steps. The first step is to generate a social network. The second step is generate a multimodal dataset. Okay. So the LDBC is implemented on MapReduce. So it will use multiple MapReduce phases to generate the data. Okay, so this phase took total execution time 134 seconds. And under the LDBC directory, we can see the social network graph has been generated. Okay, so the next steps is to generate the multimodal dataset. So the UniBench data generator is implemented on SQL, on Spark SQL. So this process will assign multiple executors to generate the data. Okay, this process took total time 160 seconds. And you can find the data under the UniBench, including the CSV products, the invoice, the order, the feedback rating, and the windows. And the next step is to benchmark the ArangoDB with UniBench. First of all, we import the generated data set to ArangoDB. We use our data importing script for ArangoDB. And we use the 8 thread to import the data in parallel. Okay, so the importing process took 2 minutes and 15 seconds, and all the data has been imported. So by looking at the ArangoDB web interface, we can see the ArangoDB uses 2 types of collection to store the data. The vertices collection and the age collection. So for the document collection, so each document will be treated as a row, and each row is represented as a document with the ID, revision key, and the primary key. And each age collection represents an age from a vertex to another vertex, and the age can have the attribute. And the next steps is use UniBench to do a power test, meaning that we will run the queries in a sequence. And the running time for each query will be reported. We can also do an in-depth analysis in the ArangoDB web interface. We take a query 5 as an example. So this query first find the friends of a given customer and their bought orders in brand of Derby. And finally, we'll find the related tags for these friends. And so this query take roughly 9 seconds, and the results will be returned as tables and or JSON format. By explaining the queries, we can see what indexes and what's the graph traversal and what's the optimization rules have been applied. And for the execution plan, the query optimizer may make an estimate for each node in the execution plan. So here we can see for the cross-model join between the order and the graph. So due to there are no indexes available, so the estimation cost is much higher than other nodes. Thank you. Thanks for your watching.